All right, today we are talking symmetry. Yes, just like in elementary school when you drew the lines of symmetry on the shapes. Remember doing that? Yes, same idea. So, but now we're talking about different graphs, okay? So if I take a look at a graph, if it is symmetrical over the y-axis, I would basically need to be able to fold it along the y-axis, and the two sides have to match up perfectly, as seen in this example. Then I have symmetry over the x-axis, same idea, folded along the x-axis, and those two would have to match up. And then over the origin is a little weird. I almost imagine folding it twice, so folding it on the x and on the y. And then if you kind of do that double one, you can also think about it as taking this and rotating it all the way around, and they'd have to match up. Okay, so that would be symmetry over the origin. You can also do symmetry over particular lines if you wanted. So for example, let me just sketch for you. You could have something that looked kind of like this. That was my x and y axis, and let's say we had the line, I don't know, y equals 2 or something. And then you had a graph that looked like that. Okay, well that graph would be symmetrical over the line y equals 2, even though it wouldn't be over the x-axis or the y-axis or the origin. Okay, so that's possible also. All right, so what we want to do is we want to be able to test if an equation has any one of these symmetries. The problem is you're not always going to, if you have the picture of the graph right in front of you, well then it's pretty easy because you can just do it visually. But of course, we don't always have a picture of the graph, and sometimes it's way more complicated to make the graph than it is to just do the tests. All right, so down here below, you will see what the 3 tests are. So if you want to test if it is symmetrical over the y-axis, all you're going to do is replace x with negative x, simplify your equation, and see if it matches the original. If they are 100% the same, then yes, this thing could be folded over the y-axis and they're going to match up perfectly. Okay, we'll do some examples in a second. For x-axis, same idea, but I'm replacing y with negative y. So it's whatever I want to test for, I want to replace the opposite variable with its inverse, right? So I would replace y with negative y to test for x-axis symmetry. Again, I'm going to simplify, test to see if they are, my new equation and the original are 100% the same. If they are, it's got x-axis symmetry. Okay, and then to test over the origin, I'm going to replace x and y, both of them at the same time, with negative x and negative y. And do the same thing. Simplify my equation and see if it matches the original. All right, so let's give this a shot. If you flip your paper over, there's a couple that we're going to do here. All right, I'm actually going to do them on this magic notebook so I can upload the examples when we're done. Let's see, let me get a couple pens here. All right, let me just title this symmetry, symmetry note sheet, notes, examples. All right, so if we look at the first one, it's y equals negative 4x plus 1. Okay, now it doesn't matter if you test for x-axis first, y-axis first, origin, it doesn't matter. You do it however you want, just make sure you're keeping track of what you're doing when. Okay, so I don't know, let's do y-axis first, just because it's first on our note sheet. So if I want to test for y-axis symmetry, I'm supposed to plug in negative x, right? So it's going to look like this, y equals negative 4 times negative x plus 1. So if I just simplify what I have now, okay, well that's positive 4x plus 1. Does that match my original exactly? No, it does not. So this thing does not have y-axis symmetry. Let's try for x-axis symmetry. So to test for x-axis symmetry, I do what? I plug in negative y. So I can divide everything by negative 1, get 4x minus 1, which does not match my original, correct? So that's a no. And then to test over the origin, I'm going to plug in negative x and negative y. All right, so let me just slide on over here. Origin. So negative y equals negative 4 times negative x plus 1. And let's simplify and see if we can get somewhere. Negative y equals now positive 4x plus 1. Divide everything by a negative 1. Does it match my original? No, it's close, but it's not. It has to be identical, and it's not. That one's got a minus 1, that's got a plus 1. So this one's a no. It is not symmetrical over any of these three. Oh, yep, it's just a straight line that does not have anything, because some straight lines will, right? But this one doesn't. Just no for each one. Yep, yep, because each one's a test. So, yep. Let's try the second one. The second, or they're not numbered, I guess. Let's try the one to the right that says y squared equals x minus 6. All right. So, to do that y-axis, tell me again, what do I do for the test? Plug in negative x, right. There's not really much for me to simplify here, right, because I'm trying to make it look like my original, and there's, I mean, you could take the square root of both sides, but then I just have to undo that. Is this ever going to look like the original? No. So this is a no. Let's try x-axis. So for x-axis, remember we plug in plug in negative y, right? So, all right, this is interesting now. So when you plug, look at my original. I'm going to replace whatever y is with negative y. This, as it is saying take whatever y is and square it. So if I'm going to replace that with a negative, how do I have to write it? You have to put it in parentheses. And it's a big difference, because without parentheses, it's not the same thing. I am now, whatever that is, I'm going to square it. So in order to do negative y squared, it has to be put in parentheses. X minus 6. Now, I can simplify this. What is negative y squared? It does come out to be y squared equals x minus 6. Which does match my original. So that means this thing, if you were to graph it, you would be able to fold it over the x-axis, and those two halves are going to match exactly. So this is a yes. It is symmetrical over the x-axis. By the way, does anybody know the shape of this graph? If you had to guess, what might it look like? It's a parabola on its side, exactly. It's like instead of a U, now it's a C. Isn't that neat? So if you have y squared, slide away as parabola. All right, let's test for the origin. So we have to do negative y and negative x. So even though I can simplify this side and get y squared, I still have that negative x minus 6, which does not match my original. So the origin is a no. Okay, how about you try the third one without me guiding you through it? And we'll see if we, by third I mean y equals 5 minus x squared. try that one. I'll do it up here too, so only look up at my screen when you're done, and we'll see if we all match. Are we in agreement? Yeah? Okay. All right, let's try the fourth one then together. This one is a little bit trickier because we have a few more things going on. X squared plus 2xy equals 5. All right, so that y-axis, let's see. Plug in negative x. What do we say to the y-axis? Yeah, I'm going to say a no because it does not match identically because that turned into a negative, right? Too bad, so sad. All right, the x-axis. Same thing happens, doesn't it? Another one that's a no. And the origin, let's try. Yep.
So if the negative x wasn't in the parentheses, what would it
Like if you didn't put parentheses there?
yeah.
So if you have this, that's really negative x squared. So let me do it with numbers if that's okay. If you have negative 3 and you square it, what's that? 9, right? This is very commonly mistakenly claimed to be 9, but it's not. That's negative 9. Because this notation, when you write it like that without the parentheses, this means to do 3 squared and then take its opposite. So that is negative 9. But it gets very confusing because in our heads we say negative 3 squared, and you say here negative 3 squared. You're saying the same thing in your brain, but the way that it's written is completely different. And that is a very, very common mistake. And so if you ever just want to test yourself because you can't remember, if you can get your hands on a graphing or a scientific calculator, watch. Negative 3 squared without the parentheses is in fact negative 9, but if you throw it in those parentheses, big difference, right? So you have to be careful. And you have to be careful when you're, even if you know that in your brain, if you're doing calculations on a calculator and you don't put it in parentheses, the calculator doesn't know what your intentions are, right? So you have to be really, I'm glad that this point came, oh, whoops. You need to be very mindful when you're typing things in, that you're typing it in the way that you mean to be. Okay? So, did that answer your question?
Yeah.
Okay, good. All right. So now we are up to 5. So right, we all got the same things, right? No, no, yes? All right. And the 5th one. Ooh, 2 absolute values. Why don't you guess before we do this one? Guess what you think this is going to turn out to be. And then we'll test. See what we get. I actually don't know either. I'm going to guess. All right. I have my guess. So, y-axis. I'm realizing my guess was wrong. Do we get the same thing here? Or can, well, this one's a little weird. Is this the same as this? Well, yeah. So their values are, if I were to simplify the original, couldn't I just turn it into x plus y equals 1? Because the absolute value of x is x, and the absolute value of y is y. So then here I get x plus y equals 1. So, a yes on the y-axis. All right, let's try x. Oh, sorry. I should zoom in a little bit. Okay, well this is just going to come out to be the same thing, right? So I'd have absolute value of x plus negative y equals 1. So again, I just get that x plus y equals 1. So, a yes. And how about the origin? If I replace both negative x and a negative y, bless you. Okay, one left. Y equals absolute value of x plus 9. Okay, which is y equals x plus 9, right? If I just simplify that original. So let's see if I can get back to it. Oops. So a yes on the y. Let's try x though. Here I can't get back to that original. Do you agree? Yeah, even if I could divide by that negative 1, but no matter how you slice it, that one's going to be a no. And then the origin. Another no. Okay, so if you look back at the examples, it's kind of interesting that it's not always a telltale, like you could have all 3 of them no, you can have just a yes on any one of the 3, right? You could have yeses on all of them. So they're not always indicative, like if it doesn't, one doesn't always lead to the other. All right, so I have some practice for you to try on this. Let's stop this here.